Welcome to another episode for Club Run Divider about reverse engineering PUBG Lite. Today with SeMi,
Hello, everyone.
and we're in the middle of something already, so let me first explain what we try to do here. So, we already have a client and a server that is running, which then obviously can make recordings for us of the initial traffic, including replication data. We then want to find out how these packets are made, and we have a huge log for this, like 11 megabytes, with lots of data in it, which is very hard to sift through by hand. So instead, I wrote a tool that just lets me scroll through all of this, and it shows me the calling stack of every bit write into any bit reader that we have. If we look into most packets here, it's just an acknowledgement. There can be multiple packets in one. I can show this here. Yeah, so we have a bunch of egg files at the start, and then maybe some bigger package at the end. So they can have random order. What's interesting here is just channel index and the payload, obviously, which we are interested in. Second. So we are not interested in the egg packets, we are interested in the actual replication packets. And somewhere in here we already found that. There you have it. So the character has a character movement component attached to it, which gets called in regular intervals to call the replicate move to server function. And after some taking stuff apart, we actually come to the function f replication layout send properties for RPC. And we also know the code line where it will return, so we can look it up in the code. So it's at here 3304, and that's essentially the next line after the one that just wrote a bit. So we already know this is the send bit. And yeah, that's already our first information. And now we just go on and then try to adapt this code here that takes the packets apart to also read the stuff for us that's in here, or at least take it apart to see if he gets the information out that we expect. Yeah. SeMi, you've got anything to add?
I don't think so right now.
Okay. Let me know if. Okay, so the next one that gets into this packet also should come from send properties for RPC, but this time serialized properties. So this should be this function here. So where we at? Serialized properties. Okay. Line 3210. 3210. This is where we return. This is not a shipping build or test build. It's just sending stuff. Okay. Net serialize item.
Yeah, like in the mid if statement.
What line?
3000. Yeah, here.
Okay. Oh, okay. Haha. Do we have implementation for this? Because this is
Should be
very
somewhere.
generic. But I assume every Unreal object which has its metadata structure in memory knows how to take itself apart. But I'm not sure yet. Okay, while this is looking, we can already... Ah, shit. I cannot cancel it. Oh, yeah. Net serialize item. You know, my tool that can read all the pack files and extract assets from it. This is also just serializing code, just not net, just regular serialized item or serialized property. This here, yeah, this one. So if you ever want to know how to read the binary data of the stuff that's in there, that's how it's explained or defined essentially. You have an archive. Let's make this bigger. That can either read or is either loading or saving. And if it's loading, it will read from here into that. So let's say 4 bytes and another 4 bytes. And if it's writing, then it will just save them in the other order. So first this, then this. So yeah, so the order is the same. Has to be. And obviously for all kind of properties that we have here, they have a specific net version. Let's take one. Array property. Deprecated code path. Great. Serialized. Okay, we will probably see what it is if we just look into the log. Sequence serializer. What? Ooh, property net serialized item. From where? Let's see if we can find that. UE4. Engine source. What? Wait. That's... Ditto? Huh? Am I stupid? Where's the engine? It should be in here. Unreal engine source runtime. Runtime. Ah. Okay. Engine. Probably private. U object. Ooh. This will be a big file. Do you see it somewhere? Runtime. Oh, core object. Sorry. This is very private. Runtime. Source. Runtime. Core U object. Oh, core U object. Private. Property. Okay. How many? Oh, this is just a generic function, right? 734. Okay.
These are the worst.
Serialize item. Yeah, that could be. Come on, let me find this. Oh, there are only 3 implementations. And this looks just like regular serializing codes that I found from the pack files. Okay. So Unreal type. So this is the actual call that writes the that calls the serialize function. What property is that? With equality in serializer. Float. Okay, that makes sense. Because pretty much everything is floats in a 3D math. Public. Okay. Unreal type. 1106. That is definitely not possible. Oh, wrong file. Okay, so about here. Come on. Elf 1106. So from this property, it just gives me its value. And is serializing this with just bitwriter serialize. Let's ignore that and go to the actual serialize function. Do I have that as a bookmark? Where are my bookmarks? No, send buffer. Have you used that anywhere else? Right bit, right interrupt. Alright, let's find it this way then.
This replication stuff is pretty hard to understand.
Yeah. Then once you understand it, it just looks like magic that it works so nice. You just define a structure and it figures out itself how to put it apart. But yeah, first we have to reverse that magic before we can use it.
Yeah, I mean, NNT packets were also hard to understand at first.
What is IntelliSense doing so slow today? Oh, it already found some, okay. So right bit, we also have Serialize. Just serialize. This would need a size. If it really called that. Private 105. Oh, this is actually a serialized int. Yeah. Private serialization bitwriter 105. Oof. I mean, we are so close to it. Insertion macros on stack walk. Okay. Huh. So can you tell me how it does the conversation then? Come on. I know I can click that. Finally. Okay,
What?
great. What do we give back here? Can be...
I have some suspicions that it's wrong.
Two things. What does this give back here? This is a structure. It could contain the data and the length. And it could have itself an overload to put this into the archive. So that's why this is kind of neat. If you serialize stuff this way, it can be a really complex object, and it will just call the internal serialize function to actually facilitate loading and saving. Come on. Let's see what it has found so far. Void pointer. So how is the void pointer serialized? Without knowing its size. You know, at this point I would love to make a breakpoint here to find it out in more detail. Also, I would really like to know why the stack walk isn't matching. $105. Ah, I can't even go back there. Stay here. Bitwriter 105. I mean, this is where it returns. But at no point it calls the other function. Set overflow. Great, they copied their own code. Alright, so void pointer would at least fit. Versus this. Let me quickly check something. What is value? It's just a void pointer. Yeah, and from that, sure, just get a void pointer back. So that would fit here. I assume in all this serializing logic, it will fill out the size of whatever is there it's pointing at. You see, void pointers, it's just an address somewhere in memory. I want to copy it. Okay, never mind. So, walking back in stack, the actual function that does the sending. Oh, do we ever get back? Seems not so. Serialize item. Property. Wait, I'm in the wrong. View object. What? View object. In private. Oh, that's public. Property. Serialize item. Net serialize item. Is it already too generic or is it specific enough? I mean, it was called from this function above it. Never mind, let's take that. I wanna move on. Still stuff to find out here. Right. Oh, net serialize item. Net serialize item. Okay, whatever. Let's just take this. Next one. Wait. Is this from the egg? Oh. Right bit. I think I know what happens here. There will be a few of these. This one. It's already something different. Okay, so we go back here. Will we ever get back there? Yeah, okay. Right. So it iterates through all the parent. Why is it parents? Should be children, I guess. But yeah, it loops through all the properties and checks if it if it wants to sense this property or not with a single bit write. So that's why we see one bit write, that's probably 1, and then all the stuff that goes into it, or whatever it's serialized here, and then nope, 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 yes again, and then we have some other stuff.
Yeah, it seems like it.
Then we serialize the properties, but this time we end up somewhere else. Net serialize item. F archive, okay. Internal write. packed int. Anything else? Nope. And we can already tell that this is something package map client. Package map client. So again, it's calling the serialized item, but this time it's not just a void pointer like this time. This time we have a U package map client type, I guess, object. That's the item. And it has its internal functions to write itself. Serialize impact, yeah, that's the one I added to the bit reader. And then it calls actual serialize, okay. Oof. So, okay. Nothing. Something. Wait, are we still at server move, core remote, internal, send properties for RPC, okay, good. Now we have actually payload data, I would say. Serialized bits. Directly. U byte property. So next comes a byte property. Okay. So we can essentially write down that we expect whatever this type is, T property with equality in serializer, so a float in something, I guess. So this is a float. This is a U package map client object. This is just a U byte property. Does this come from the same call? Oh! Now we already write the header and the payload, so that was it. So we have this. You byte prop 1, 2, 3. And this is something totally else. Okay, so from here to here, that's replication data that we have for that specific packet. It's interesting. What I also don't know yet is when we have these long payloads, do they just contain more packets and have a header as well? That would be interesting to know. Okay, so we don't really need to write down this because we cannot predict what will be next. Well, we can because it's fixed right now and we could just write it out. But it would be more interesting to find out where this data comes from. And I'm pretty sure this comes from the pack files. The problem is I don't think we can open the pack files with my tool. I would have to adapt it. Project. Ah shit, what was I about to do? Shit. Hey SeMi, are you still there? You're so quiet.
Yes, I'm here.
Alright, I was looking for pack files. Man, it's late. Relight. Build. Content. Why is it so slow? Pucks. How many do we have? Just one. Okay. Just a second, hopefully. Hello? Come on. I just want to open the tool. Can't be so hard. I really should make a shortcut for that. It's a big program. Needs like 1 megabyte. Let's see how long it will take to load this then. 125 megabytes. Okay, yeah, this is not encrypted. I don't have my tool here. No, I don't think so. PubgLite. Nope. Nope. I only have the game here, but not the Explorer for it. Actually, let's just quickly download this. Wait. First I wanna figure out why this is so slow. Come on! System interrupts. Sounds like security issue again. Just do you? Oh, I think why. I know why. Is this still... Oh, it's ready. Okay. Why is there... Yeah, it's still off. Should work. The hell? Could we open it yet? Yeah, okay, that's fine. Now this will slow everything down. Ooh, I should have prepared this. I'm sorry.
That's weird.
Hmm.
You can't search this as your live stream is not lagging.
At least something. I mean, I'm recording it from my side anyway, but yeah, I'm pretty sure the system outside the VM is doing some updates or whatever. But yeah, not now. I mean, also I can cut the video at this point and then just code. Give me code. Keep on loading. So yeah, I think I will have to adapt this tool for our own pack files, so we can see how the structure is supposed to be, that is getting replicated. And we can't really adapt our well, we can adapt our dissector code for it, so the Wireshark can make better outputs. Well, it would be very specific for our games. This wouldn't be universal for any Unreal game. Can we finally do this? But again, if it's not the connection, it's internet connection, then what is lagging so? I have like 24 cores on this machine. This should not be an issue.
Yeah, it's weird.
Oh, it's doing something. I mean, there's another way to get recording time, but that's not how I wanted this to be. 400 kilobytes, come on. It's not that I'm impatient, but this is really annoying.
Yeah, it is.
Will it open or will it not? Oh, it does. Too slow for double clicks. Go away. Two megabyte. Oh my god. I'm always tempted to already start another action in another window, but I guess it would finally kill it. Can I finally please open this? I mean, you can't have enough Visual Studio open. Hello, Microsoft. Please fix that. There also was an update for Windows 11 today that well, let's not say it did good things to my PC, and I had to uninstall that. I don't know if this is maybe residue of that. Uninstalling an update.
In my case, Microsoft forced an update to Windows 11.
Well, this is a Dell laptop. It has updates from Dell sometimes as well. So there was a BIOS update also 2 days ago or so. I don't know. This all shouldn't make this so slow.
Yeah, it's weird.
Okay, maybe just not enough memory. So it's caching a lot. Actually, let's check that. Nah, there's plenty. 16 gig. Okay, never mind. And no, I did not click on you. Oh, I did. Hello.
I'm here.
Let's ignore that. Let's see if I saved my ass. And it already just works. Will it, won't it? Close it. I don't not. Let's report about it. Let's make a log about it. Inform the user about it. I just want to kill this task. Finally. Can I get back control of my PC now? Did I miss something? Is there a message? Doesn't even has to build it, just has to run it. Okay, let's see if I can just run the exe file. That's definitely a preview effect. I want to record something and the machine just doesn't want to. Oh no, it feels like building it. Ooh, it started. Load a single pack file. Ah damn. And again. Oh wait, can I just go back? Man, I really try, but it's hard. This one. Okay, probably fast. Just do it this way. What? I haven't clicked anything. Still not doing what I want. Content. Please give me the path. And it crashes. Okay, let's see why. I can probably fix it. Terminate? Whatever that was. Okay, let's see. Can we read the header? No, we can't. Come on, let me go there. Alright, the magic is probably wrong. Let's see what we get. There's my play button. Oh yeah. So we got... Okay, something totally different. Let's say this is light. That's the simplest case. Don't overheat while building. What is it doing? Oh yeah, I'm not sure if I can finish this inside this video. Well, let's see how far we get. Just wanna see the contents. Yeah, this will be bad. Because it's encrypted for PubgLite. And that should be enough to see the contents. Let's just go. Ah, nice. There we are. There's your content. Content. Blueprints. Core. And this will probably crash. No! Interesting. Can actually read the properties. Nice. Oh no, we can't. Why can it not resize this? So, scene component, blueprint generated class. Name property, object property, yeah, that's probably not it. Okay, so the idea would be to find out which of these objects actually get serialized here. But I'm not sure if we can find this right now.
I think I saw the char move comp and the char actor mesh. Like remember the one payload that you have sent me, where you sent after reading 2 bits, it becomes readable. So I think inside that payload was char move comp and char actor mesh 0. I can.
Sure,
I
yeah.
think. Sure, so, yeah.
But it doesn't help us find it in here. So, if you think about it, for example, the default class here, it has a root object, number 4. Yeah, this is this node. This internally should have references to the other objects here, or by name. Not quite sure. Anyway, these construction scripts. One of these nodes tell us how this blueprint is structured in memory. It has a position and that it has stuff attached to it. But yeah, I'm looking for that, I already closed it, player move component or so. This should have been referenced here anywhere. Character.
No, the char move component, but
Character movement component. Root component, collision cylinder. Capsule component, okay. I don't know, we don't have to find everything out. I think we are over time anyway. But yeah, like you have object and struct properties here. We had these byte properties and these, well, more complicated classes that get serialized. And so the next step would be to find where that matches. Wait, is it maybe in the engine? Oh no, it's just engine specific stuff. Yeah. Okay, never mind. Well, I think this is a good place as any to stop. If anybody is still watching this and wants to know what we actually found out now, is let me summarize it. Maybe we should do this on every episode to summarize it at the end. We started with packets. That was data from here, mostly down here. That we can already take apart, look into it, see its data, and this data in here is now, well, it can be more complicated, it could be multiple things in here. But actually, we saw in the listing of the who wrote what into the packet, that after our replication data was done, it already made the header and payload for it. So this would be the header, this would be the payload. So I think we were just looking at stuff like this or something shorter. I don't know, this first serialized call that just had a void pointer, this could have any length and could itself contain more data that could be decoded. But yeah, we know that this is related to the structure of the, in this case player object, as an Unreal object inside the Unreal Engine while it's running. So it has properties, position, is it jumping, is it falling, stuff like that. A lot of these properties get not replicated, so that's why we see a lot of bit writes that just write a 0 and nothing else gets serialized. But some of the properties, like that one U byte property, those are marked to get serialized and will be serialized. So we have to find these in the content essentially to find out what we should expect, what field types get serialized, and should be able to match this with the logging that we have. From that, we can reverse the same thing for PubgLite and figure out how our structure differs from the one from PubgLite, and then make ours fit it. So it should hopefully accept our server and our data then. Did I miss anything? I think that's it.
no, I think you said everything.
Alright, so Have a nice evening, whoever's watching this, and see ya next time.
Goodbye.